Welcome to the tutorial video for the IDNAC point-to-point circuit designer for Johnson Controls addressable notification devices. This new tool is designed to facilitate easy and accurate design and layout of the IDNAC addressable notification circuits. Key features include fast and simple device selection spreadsheet, voltage drop and current calculation support for Class A, B, and mixed A-B circuits, easy calculation of T-tap circuits, IDNAC repeater support for Class A, Class B, and extended mode selections, a circuit tree view with easily identifiable tap levels, exportable project view for submittal packages, and the creation of a one-line riser drawing of your circuit. Please note that Microsoft Excel is required to run the IDNAC point-to-point circuit designer. The circuit designer is a macro-enabled Microsoft Excel workbook, so you will have to enable the content in order for the macros to run. When you do, a pop-up window will appear and you have to accept the warranty disclaimer and software license agreement. Next, you should choose your brand. This works for both simplex and autocall. The functionality is identical. We're going to use autocall here. And next, you'll see circuit designer, FQQ, some other functionality, but really this is two tools in one. The circuit designer is how we lay out and design IDNAC circuits. The FQQ, the featured quick quote, is a takeoff tool. We'll talk some more about that in a separate training video. So I'm going to open the circuit designer. Across the top, you have function buttons. These function buttons are also shown in the overhead toolbar. The center section has your info panel, and then the actual circuit designer is here in the bottom. I can hide this info panel by clicking the hide info panel button and it will toggle closed. I can also, from up top here, reopen it. Here's where you'd set your parameters. You have your wire length between devices. You can change the default. As you enter devices, if you have one device that's drastically different than the other ones, that can be changed in the body as we go. But this is your parameters. Your set defaults 50 per, 14 gauge wire can be changed. Your device application use, we default to fire, but if you're doing emergency communication systems, you can make it alert or any other of these items. You can enter your project name, customer name, project phase, your name, the date, where the circuit's located, and then you have your imperial versus metric and your temperature of your wire, which affects the resistance per foot. I'm going to leave these as is because it can function exactly as it comes out of the box. So let's hide the info panel. Start looking at the designer. Part code entry is for advanced users or people who are very familiar with the PIDs, and they can enter these in manually if they'd like. As they start to put in A49AV-APPLW and they hit enter, it will search the database. It's going to find the matching part and populate that line. So we have a wall horn strobe at 15 candela, 50 feet, as we showed above, 14 gauge wire, it's fire use, and it put an address of number 1 in here for the first device. You don't have to use this field because a lot of people don't know the PID numbers. So if you're not going to, let's hide it. The next item is the point label. If you're just doing a circuit design for estimating purposes, you may not care where the devices are located. You're just trying to figure out how many devices can fit on a channel. Then you might hide this label. If you've won the job and now you're preparing documents to submit to the AHJ, then you might leave this open and put some descriptors in here. Horn strobe would be here, and you might put hallway 101, hallway 107, etc. That way you know what devices that you're laying out. Then we have these functionality buttons which use the Microsoft embedded tools. We can copy and paste, we can insert a row, we can remove a row. That can be done up here as well. I caution you not to use the Control-C, Control-V functions, that shortcuts that everybody knows how to use, because if you accidentally overwrite a row that or a cell that has data in it, you can cause the workbook to stop functioning correctly. So it's best to use these functions up here. Class A calculations. If I'm doing a Class A circuit, we'll want these to show, but if not, let's go ahead and hide them. The readdress devices button, reset T-taps, and reset project are all functions that can't be undone. So when you click them, it will ask you, are you sure? So if I go to reset project, it's going to say, are you sure you want to reset it? Once it's gone, it's gone unless you saved it. So I'll say yes. I didn't have anything in there yet. The other buttons crossed here are the project view and the circuit drawing. There's nothing to show here yet because we haven't built a circuit. So let's add our first device. So this column is where I would select what I want to add. So let's put a wall horn strobe in. And when I do, it will populate the rest of the line. Wall horn strobe, it chose 15 candela. There's the 50 feet that we decided on in the top, 14 gauge wire, and it's a fire application use. And address number 1 was assigned to it. This first device is attached to the branch circuit. The branch is the IDNAC at the source, at the control panel, at the transponder, wherever the card is that started, that is the branch circuit. I can change these devices. So I threw it in there as a 15 candela, but maybe it's actually a 75 candela. That can be changed on the fly. You can also change the wire length. If I go back and look, well, actually the first device was 75 feet from the panel and everything else is going to be 50 feet spacing. That can be changed here. You'll notice that we started at the branch at our 29 volts, which is the starting voltage for the IDNAC. Our first device has dropped us down to 28.95. It used 107 milliamps. I can open back up the info panel, and you'll see here that so far we've used 0.11 amps. We have one branch circuit, we have one address and one unit load. We'll hide this one, let's add another device. I can choose again wall horn strobe if I like. And it puts the it'll revert to the 15 candela. I can also copy and paste. Both those are highlighted. If I copy, paste, it's going to put both them below here. My voltage has dropped down to 28.71. I've addressed my devices 1 through 4. I realize as I'm looking at my drawing that I forgot that there were a couple of bathroom strobes right here in the middle of this. Do I need to delete these to start over? I don't. I can insert a row. So I come up top and say insert a row once, insert a row twice. Let's make this a wall strobe. It'll put it in at 15 candela. Wall strobe second time. And we are down to 28.51 volts. So this column that I've been adding devices in, it has all of our addressable notification appliances, all the way from, let me show you the next one. We have our horn strobes, multi-tone horns, strobes, speakers, speaker strobes, all the way down even to the isolator modules and the addressable adapter modules. Then below that, we have some other things, branch, T-tap, junction box, repeater, etc. What do those mean? If you'll click on this type and tap definitions button at the top, it opens up a new window. It's a floating window you can put to the side if you'd like. So the branch means we're connected directly to the IDNAC, as we've done here. We can also do that further down on the circuit. So these 6 devices all came off directly off the branch, and maybe they went to the east side of the building. Well, now we decide we've finished that portion of the circuit out. We want to go and do the west side of the building. If I were doing conventional notification, I would have to bring a pair of return wires back from that last device, this one, come back the way that I'd already gone and tie to the circuit that's going to feed the west side. With addressable notification, you don't have to do that. I can come off the panel and I can go two different directions. I can go east with this circuit, and off the same pair of terminals on the panel, I can go west. How do I show that? I need to add a branch here. So if I say branch, it's going to run across, and I'm starting at the panel again, 29 volts. So far I've used some of the amperage from the panel, and we can see how much we'd like. We can show the info panel and say, so far I have used 0.43 amps, 430 mils. I still have 2.5 amps left. Starting here to do the west side of the circuit, I'm at my fresh 29 volts again. So let's say those two circuits are identical. Let's grab those items. We will copy, and they're going to paste. So now I have this circuit has whatever the distance is from here, this distance, and both of them are sitting at 28.51 volts. Other items I can insert are junction boxes, terminal cabinets, repeaters, and we'll show you the DCAI Class A stuff in a minute. So let's rethink this whole circuit and consider that the panel's on the first floor, but this circuit is up on the 6th floor. So I have to run my wire run to get from the first floor up to the 6th floor before I start. How do I do that? Well, let's go ahead and insert at the very first device. Get rid of this. Let's insert a row. I'm going to put a terminal cabinet in here. Terminal cabinet. It does not have an address, of course. It doesn't have a candela, but it does have a distance. So can I get up to the 6th floor in 50 feet? I doubt it. Maybe it'll be 90 feet. Now we've gone from the IDNAC branch down at the panel. We've gone 90 feet up to a terminal cabinet. Then we're starting to feed the floor left and right. So we've now inserted a terminal cabinet on the 6th floor. We've given ourselves 90 feet of wire to get up to the 6th floor, and we've started our east side of the circuit. Let's make a quick notation east so I can keep track of it. Here's the end of the east. And this is the west circuit. But I have a branch set up here. So here's the problem. We leave the branch down the first floor. We go 90 feet up to the terminal cabinet. We fit these east devices. But because I've told this branch, the west circuit is going all the way down to the first floor as well. There's no need to have this 90 feet of run and this 90 feet of run as well. What I'm going to do now is I'm going to delete this row. So remove it. Okay, so now this is the start of my west circuit. And now we go over to the tap column. So far, everything is connected one device to the next to the next. And that's shown up here in the tap definitions by that straight line. We started at 29 volts down the first floor. Our 90 feet to get upstairs dropped to 28.57, and then we drop for each individual device. This row is the start of the west circuit. So how do I make that connect to this terminal cabinet? I change this tap definition to a TC, terminal cabinet, and it's going to scan up the page and say, where's the next terminal cabinet above me? It found it. So now this device number 7 directly connects to the terminal cabinet. When we look in our device addresses, we have some holes or some things that are missing here. Because I've been inserting and deleting and moving stuff around, it's jumbled the addresses. We can wait till the end and fix this. We're able to readdress all the addresses at one time. If I go and I do a bunch of tap changes and I realize that I've messed up and it's easier to start over than try to figure it out, I can also reset the taps. Both of these buttons that you would click. Say, are you sure? Do you really want to do it? Because you can't undo it. So now we have the first floor coming 90 feet up to the terminal cabinet. I feed my east devices. My west device connects directly to the terminal cabinet. I've still got a lot of room. I can go all the way down to 23 volts on this. So let's add some more circuits. We'll make this west circuit quite a bit bigger. So I'm going to highlight those, copy and paste. We'll do it again. Copy and paste. All right, so the west side is quite a bit larger than the east side. Maybe there's going to be some future expansion on the east side, and we want to leave some more, some power there. So we're going to stop here. We're going to add a repeater into the system. So at this point, I'm going to scroll down and say a repeater. Currently, the way, because of this straight line, I'm directly connected to the end of the circuit. As I look at my page, though, I realize, see these TCs? I don't really want that. This is the only place I want to connect to the terminal cabinet was here. So I need to go back and just fix these and go, now this is a direct line to the device above. This is a direct line to the device above. It's all this stuff is very easily fixed. You just scroll back, as you see, whenever you copy and paste, you get the entire line item all the way across. So now, this east circuit ties the terminal cabinet. The west circuit ties to the terminal cabinet with a repeater in series. Well, maybe I don't want that repeater in series here. It's going to be right next to the terminal cabinet, feeding the north and south circuits. How do I fix that? The same way I did with this up here. I say, let's connect this to the terminal cabinet. It scrolls up the page, finds out the next place above me where there was a terminal cabinet, and it parallels it next to it. It T-taps the circuit. So we're tapped in 3 places. We came up with the branch, we went to the terminal cabinet. This is a tap, this is a tap, and now everything downstream from this repeater is another tap. So in the tap column, I've showed you how to connect to a branch and how to connect to a terminal cabinet above. There are other options that we can look at. We have the a J box. We have the repeater we show how to do a branch, and then all the stuff up top is how to T-tap. So if you wanted to insert a J box somewhere to show in your drawings, you could insert the J, and then let's do that. We'll insert a J box, insert a row. It moves everything down over here. It's a direct connect. I'm going to insert a J box. And if I were going to tap devices off that J box, I could actually show that down here, and I could say I'm connected to the closest J box, and what it does, it's like a branch out at the J box. So there's very, very fluid, very versatile in the things you can do. Probably going to get rid of that. I just want to show you how to use it. So let's remove that row. So let's talk about T-taps. So the beauty of addressable notification is the fact that I don't have to bring return wires back from the ends of circuits to feed other parts of the building. So let's assume they're running down a hallway and there are a pair of bathrooms that are next to the hallway. If I were Class B conventional or Class A conventional, I would have to deviate from the hallway path. I would have to turn right to go into the bathrooms, hit those devices, and then when I'm at the end of the bathroom, I would have to bring a return pair of wires back to the hallway to head out. With addressable notification, I can tap off the hallway device, run a single pair of wires to the first bathroom to the second bathroom, and just stop there. And back in the hallway, I would continue down the original path that I was heading. So how do I show that here? So let's say that these two devices are the bathroom devices. I can use this tap column over here. Here's the first bathroom. And when I do this right arrow button or the greater than symbol, you can see what happens. These devices are now, they indent one line. They are tapped off of this. The second bathroom device, it's also part of that circuit, but here I'm returning back to the hallway. So I can use the left arrow to take me back, and you'll see that the indentation changes. So we've left the terminal cabinet, we've gone to hallway device 1, hallway device 2. The bathroom and bathroom are both tapped off of there with 2 wires going out and not returning. And then at this device, we're back into the hallway again. I didn't have to show any T-tap over here to do this. The magic happens in this column, but it's a little confusing. If you're looking at a drawing, you might want to see that there was a T-tap for this device. So let's show it. I'm going to take the wall strobe. I'm going to insert a row above it. And now I'm going to show a T-tap. This T-tap is done right at the wall horn strobe, so I am directly connected. I'm 0 feet because I'm directly on that device. We just went 3 wires under the screws, a wire in, a wire out, and a wire to go to the bathrooms. If I want to make a note for myself, I can say at hall device. But again, watch the tap column over here. We're running down the hall. We had a T-tap. These 2 devices are actually tapped, and now we're back to the original circuit. Then we get to the west side, and then we started all fresh again at the terminal cabinet as a terminal cabinet branch tap. I also have the ability to tap many times on a circuit. So this second, the west circuit, I could tap this out. Again, I have the option whether I want to show the T-tap here or not. The actual device was tapped just by doing this right arrow. I've hit a few devices. Maybe that taps off again. We can go further out. So each time I tap out, I'm showing an arrow. I'm showing an indentation to show me further out. Now, this circuit, this device, maybe it comes all the way back to the original hallway, the original point before I tapped it all. I have some options here. If I bring back once, it brings me back to this device, or I can say come back twice, and you'll see that now I'm tied directly to this device. See this address 1919 is tied to 19, and so it shows you where it tapped in. And if I'd put alpha descriptors over here, that would show as well in these brackets. Some other options you have for returning to taps, you have these left once, left twice, left 3 times to bring in 3 levels. If I tell it root, it brings me back to when's the last time above me that I was all the way to the left. I can also come back to the nearest J box overhead, come to the closest tap ahead. You know, a terminal cabinet, I can go back to the nearest repeater or the branch. It scans up the page and looks for whatever these items are, and that's where it will connect to. It's very versatile. So now that we have this, I'm going to open a sample project of the 5th floor of a building for us to take a look at.